Alright guys, you've made it to the last video for this package. Give yourself a little pat on the back. You're almost there. And the package I'm talking about again is just this one, slope and lines. And we started with question 1. Then in a turn of events we moved to question 2. Then you saw the videos for questions 3 and 4. And then we moved on to the surprise of some people. After 4 we did 5. But we're moving on now to the thrilling conclusion, questions 6 and 7. So question 6 and 7 tell us to first, for question 6, something we've already done, complete a table of values for this equation and then graph it. So if I were to say, okay, I know I got to write a bunch of x's here. Let me try -1 for the first x. I'm going to put that there. Then maybe a 0 is always a good idea. I'm going to put that in there. Maybe I'd like a 2 for some reason. And then, you know what, maybe just for fun I'm going to use a 3. Put in here. So now I've got my 4x values that I'm using in my table. There's no right or wrong answers for these, but it's always a good idea to have a 0 just because it makes my life easier. And then I take my equation, which is y equals -3x plus 3, and I say to myself, what I'm going to be doing is I'm going to be doing a calculation where for each of the x values that I have in that equation, in my table, I'm going to use each of them to drop into this point here, right? All I've done here from here to here is I've rewritten it, except instead of putting an x, I've put a little hole where I'm going to be dropping these x's one by one. So I drop this x, which is -1, into that hole, right? Let's try that. If I put -1 in there and I want to calculate what that will become, I do what's -3 times -1? That gives me +3. And +3 plus 3 gives me 6. So I just figured out that the answer here is 6. All right, next up, I got to get that -1 out of the way. Go away, -1. Oh, you're sticking around, eh? A wise guy? All right, there we go. -1 is gone, and instead I'm going to put in 0. See, picking 0, again, always such a great idea because it makes this so much easier. What's -3 times 0? Anything times 0 is 0. And so if I have 0 plus 3, then I know I'm going to put in a y value of 3. If I were to take 2 for my x here, put that in that space, then when I put 2 in there, I say what's -3 times 2, which is -6. -6 plus 3 gives me -3. Right? And lastly, I'm going to plug in the number 3 here, because that's what's next from my table of values. I took that x, I put it in here for 3, and then I do -3 times 3 is -9. -9 plus 3 gives me -6. All right, so now I have taken my equation and I've given myself a bunch of points on it, right? And the reason why I give myself a bunch of points is because now I can take those points and put them in the picture, right? I start off with -1 and 6. That one may be difficult to put on my graph. I go to -1, +6. That's not really on my graph. I don't really need it. I'm going to go without it, right? Next one here is 0 and 3. That's going to be easy. 0 for x, 3 for y. That's right there. And then 2 and -3. So that's 2 for x, -3 for y. And this other one, 3 and -6. That's not going to fit on my graph either. But I got 2 on there, which is going to be enough to draw a straight line. And if I draw that line, that'll go directly through both of those points I just put on there, and it goes to both edges of the graph. I have a graph of my line. Now, if you look a little further up your own page, you'll see that the graph of the line you had up there, that had a slope of -3 and a y-intercept of 3, that hits the exact same line. And we talked about why that was up there, right? Because up there it told you to draw a line with a slope of -3. Here, since I've got -3 in front of the x, it should make sense that its slope is also -3, right? They should match for having the same slope. And we also saw that if you had the y-intercept up there, it told you the y-intercept, that point was 0, 3. The fact that I have this +3 at the end of my equation, it makes sense that this line goes through the y-axis right at 3 here, just like the other one did. So that's why you have the same line when you're making this equation and when you're drawing a line that passes through 0, 3 and has a slope of -3. Really, it's the exact same thing said in different ways. All right, so You were hoping this moment would come sooner, but here you are. The last question in the package, question 7, says graph a line that goes through 0, 5 and has a slope of -2. Now you might already be thinking to yourself, I bet I could write the equation for that, right? If it's got a y-intercept of 5 and a slope of -2, then I could write that as y equals -2x plus 5. But for the purpose of answering this question, I don't even need to be that sharp. I can just say, I want a line that goes through 0 and 5, so let me put that point in there right away. And it has a slope of -2, so that means it has a rise of -2 when it has a run of 1. I can put another point right there. A rise of -2 and a run of 1. Rise of -2, run of 1. Rise of -2 and a run of 1. Rise of -2 and a run of 1. Okay, let me draw that line in now. This is my first line that has that goes through 0 and 5 and has a slope of -2. And then it says graph a second line. Maybe we'll change colors here just so we can see what we're doing. This color is called fern. Look at that, isn't that nice? So using this color fern, I'm going to graph a second line that goes through 0 and -1. So its y-intercept is 0, -1, and has a slope of 1. So that means 1 is a fraction. It's 1 over 1. That's a rise of 1 with a run of 1. So I'm going to go rise of 1, run of 1. Rise of 1, run of 1. It's already giving me the answer to my question here. Rise of 1, run of 1, rise of 1, run of 1. I'm getting all these points here. And if I were to draw my line now, which starts at one edge of the graph and is going to go through all the points, which line up perfectly, and going to go all the way to the other edge of the graph, then you see, where do they cross? Well, they cross right at this point here, which is 1 and 1. Now, you've answered the question, but I'm going to add a little extra on here. Remember how we said if you know what the slope is, and you know what the y-intercept is, you can write the equation, right? Well, here, for this first line, I know that the slope is -2. I know that the y-intercept is 5. So I can write the equation as, let me make it red so we don't get the lines confused. If I write the equation and I say y equals, I got to put the slope in front of the x. The slope is -2, so -2x plus, and then I put the y-intercept. The y-intercept here, the x is 0, the y is 5, so the y-intercept I'm going to put here 5. That's the equation for my red line. And then let's go back to, which one's fern? Well, that's spring. This is fern, good old fern. If I'm doing the equation for fern, I know that it has a slope of 1 and a y-intercept of -1. That means I could write it in my head. I'm thinking y equals 1x plus -1, except I know that I'll lose marks if I put a 1 in front of an x. I don't need to put a 1 there. So I'm just going to write it like this. Y equals x plus -1. I've got these two equations here. And if I wanted to go to the next level, I could say, well, where is it true that -2x plus 5 and x plus -1 give me the same answer? And we haven't done solving equations yet, but if you make -2x plus 5 equal to x plus -1, you might find that it's somehow related to what you're seeing here. But we'll be doing more of that later in the year, so I'll leave you on a bit of a dramatic cliffhanger note on that one.